So guys, you can see our LED is toggling, and it is toggling with a speed of 250 milliseconds. Now we didn't use the delay on off technique like we do for blinking LED in previous videos. So what we did here, let me show you the code. So this is our code. You can see that we just initialize the pin. Our LED is connected to port B, pin number F0. We initially made the pin go low. See, I am setting port B, F0, pin number B0 to be low by default. Now, once the forever loop starts, this pin is low. Now, what I do is that I use this symbol. This is equal to having a bitwise NOT gate. This symbol inverts the logic. Now, to what it will invert the logic, whatever you write next to it. So this was low by default because initially I gave it a 0 state. So once this command is executed, this makes this inverted. So this means that now it's 1. Instead of 0, now whatever the logic was here is now inverted, and then it will remain in that state for 250 milliseconds. Again, the loop repeats, and this time it is 1. Now again, this bitwise operator makes it go 0, and again it stays like this for 250 milliseconds, and again the loop repeats and keeps on repeating forever. So that is how our LED is blinking over here. You can see that is how it's going on. Guys, welcome to learning microcontrollers. In this video, I will show you how you can blink an LED with a PIC16F877A microcontroller using toggle command in MikroC for PIC. So guys, in other IDEs like Arduino IDE, MPLab, you have a toggle command directly which you use, like for the STM32 as well. In the STM32Cube IDE, you have a command called toggle. But in the MikroC, this command is not there. But you can do the same using a negation sign. So I will show you how to do the same in the MikroC for PIC with some other way, but that will do exactly the same what the toggle command does. So let's get started. So guys, this over here is our PIC16F877A having 40 pins, it's a DIP version. Our circuit will be very simple. And here we have an LED. So these are the only two components we are going to need. So an LED, this one 5mm crystal type LED I'm going to use, have 2 pins, one longer, one shorter. Longer is always the power, shorter is always the ground. The shorter pin ground, you just send it directly to the ground of your PIC like this. Now for the longer pin, that is the power pin, you will need a safety resistor. It can be of any value from 100 ohm to up to whatever value you prefer. The higher the value of the resistor, the dimmer the LED will go. So I will use a 220 ohm resistor. Now for the longer pin, you connect it to the one end of the 220 ohm resistor like this. From the other end, you can connect it to any available GPIO pin. I'm going to use a pin number B0 like this. Now first let me introduce you to the hardware, then we move on to the programming. So guys, there is our hardware. As you can see, I have a PIC16F877A. Then over there I have an LED. You can see that it's a crystal type 5mm LED, and the crystal you can also see over here. See, so this is just a simple hardware. Rest is just a trainer board. So let's get to the programming. So guys, this is our MikroC for PIC. Let me zoom in. Click on File, New Project. This window pops up, New Project Wizard. Click on Next. Write the name of the project. I write like toggle 3. And the microcontroller is PIC16F877A. Select the path where you want your files to be created. Select the crystal that you have connected to the pin number 13 and 14 of your PIC16F877A. I have a 16 MHz crystal there, so I write 16. Click on Next and Finish. Now this window pops up. Before you do anything else, first of all, save your work. Go to the file, click on Save. This window pops up. Just save it wherever you prefer. Okay. First of all, we need to initialize the pin. So as you know, from the presentation, we are using port B, pin number 0 or B0. So I use the trace register to give it the direction. So we initialize the pin B0 as an output pin. Trace B.F0 equals to 0. 0 means the pin has been declared as output, B is the port, and F0, this is the pin number, and this is the command. This is basically the name of the register, which is a direction register. It defines the direction of the pin. So this pin has been declared as output because we always connect LEDs to the GPIO output pins. Now by default, I want the LED to be off. I give it the off state, port B.F0 equals to 0. This means that I am sending a 0 to the LED in the one-time loop, so by default the LED will be off. I give some initialization delay, not necessary, but I always suggest you give it in the one-time loop. 10 milliseconds will do fine. Now let's get to the forever loop. Right, while one forever loop starts here, ends here. Inside it, I use the command port B dot F0 equals to negation of this port B dot F0. That's what we need. Now see, we don't have a toggle command directly in the MikroC for PIC. So this is our port B dot F0. Instead of sending it as 0, what I did, I just use a negation. This sign means it will invert the sign. So negation means this is basically equals to NOT gate. Like if you use this with anything, if it is 1, if by default it is 1, it will become 0. If it is 0, then it will become 1. Now by default we know that in the one time loop we have made it go 0. So by default it was 0. Once this command is executed, this will become 1. And then for how long we want it to remain high. So I make it delay ms, like it will remain high for 250 milliseconds. Okay, and after that, once the forever loop repeats again this command will be executed. Now it's 1, and NOT gate, again it will invert the logic, it will make it 0, and again the loops executes, and again the 0, now it's 0, it will again become 1, and then again it will become 1 to 0, 0 to 1, 1 to 0. This command will keep on toggling it. So this is how this command works. Basically this is equivalent to using a bitwise NOT gate. So we are using a bitwise operator to invert the logic. So that is how our LED will keep on toggling forever with a delay of 250 milliseconds. So let's build this code and try it. Let's see what happens. Okay, build without errors. Just build again. Okay, no errors. Now now open the PIC3 programmer tool. There you go, PIC3 programmer tool. I also have a lecture on that in the introductory side. Please go check out how to download and install this PIC3 programmer tool, because it is very important. Click on, first of all, you select your microcontroller. I have PIC16F877A. Click on File, Import Hex file. This is the file we just created. Click on Write. Okay, wait for the new file to be written. Once it's written, then we go to the hardware. Okay, we power up the circuit using the PIC3 programmer tool. Click on. Okay, here you go. The circuit has been powered up. So let's get to the hardware. So you can see the LED is blinking with a speed of 250 milliseconds, because we are toggling it with a speed of 250 milliseconds. So this is very simple, guys. This is it. Now this command is very useful in various programming that you will do in the future, where you need to invert the logic. Then you will use this command. So guys, this is it. So if you have any question, please do ask. So we'll see you in the next lecture. Goodbye until then.